Solving logarithmic functions, we're going to use an ln function right now, and I wanted to remind you that you're going to need to remember the quadratic formula for this one in particular. I'm going to move all my ln's to one side, so I'm going to go ahead and move this ln. So I have negative ln here, so I'm going to get, just going to rewrite the left-hand side, ln of x. Then I'm going to get plus, because I added its opposite, right? ln of x minus 2 is equal to 1. Remember, when we have logarithmic functions, if they're of the same base, and these are, because ln of x is the same as log base e of x, so these are of the same base, then this piece right here, this addition sign right there, reminds us that we have to multiply. So we're going to multiply here. We're going to multiply this. So we're going to get ln of x times x minus, the quantity x minus 2 is equal to 1, which gives us ln of x squared minus 2x, doesn't it? Oh, you know what? Forgive me, this should have been a positive. This should have been a positive. I was like, looking at one, it's different than the work I did a little earlier. It's equal to 1. It wouldn't matter, but just that's how I set it up. Now we're going to remember that this piece right here means log base e of this whole thing, right? So I'm going to put this into, so change to exponential form. And if you remember how to do that, what we're going to do is we're going to take this right here, raise it to this power, and set it equal to that. So it would look like this. It would look like x squared plus 2x is equal to e to the first power. Let me show you this just to make sure you see it. This one is this one, and I'm only showing it to you. I'm going to erase it and show it to you so you know where I got it. This e is that e. Okay? Now this is starting to look like a quadratic, isn't it? So what I'm going to do is go ahead and change this over to quadratic form and say this is x squared plus 2x. I'm going to move the e over by subtracting it from both sides. Is equal to 0. Now I'm going to use the quadratic formula and say a is equal to 1, b is equal to 2, isn't it? C is equal to e. Remember, e is a number. It's Euler's number, 2.71 or whatever it is. It's a number. This e is not a variable, so don't freak out. So I'm going to set this thing up in the quadratic formula. The quadratic formula says that x is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. That's all I'm using here, except I'm going to fill this in. And we have b is equal to 2. The opposite of 2 is negative 2. b is 2, so there's 2 here. A is 1, isn't it? C is e. A was 1. So I'm just showing you my algebra here. So I get x is equal to negative 2 plus or minus the square root of 4 minus 4e, all over 2. I could stop here and say that's enough work, but I'm going to go ahead and do some more work to show you how I'm doing this. So it is equal to the opposite of 2 plus or minus the square root of, look at this, 4 times 1 minus e. All I'm doing is factoring out the inside because I know this rule. Remember the rule of radicals is if I have the square root of the product of a times b is equal to the square root of a times the square root of b. So I can pull this square root of 4 out. So I can rewrite this like this. You can see this. That x is equal to the opposite of 2 plus or minus the square root of 4 times 1 minus e all over 2. Alright, square root of 4 is 2. There's that 2. Now, this is the last step I'm going to do, and then I'm going to stop, I think. I'm going to factor out 1, I think. I'm going to factor out 2. So it's 2 times negative 1 plus or minus the square root of 1 minus e all over 2. You can see that these things cancel out, and we get x is equal to -1 plus or minus the square root of 1 minus e. And if you wanted to, you could use a calculator there to get this answer. But if you're in college calculus or college pre-calculus, college algebra, this is a very sufficient answer for your professor, I believe. So I hope this was helpful. Who knew we'd actually ever use the quadratic formula again? Good job. Hey, if you haven't already subscribed, will you please subscribe? And if you have comments, please make them. I'd love to hear from you.